In this question, we will look into the exponential growth and decay functions. These are all real-world problems. Here we have about population. In 2000, the world population was estimated to be 6.124 billion people. In 2005, it was 6.515 billion. Write an exponential growth equation to represent the population y in billion t years after 2000. Now, what basically they want is the population growth. As you can see here, it was 6.124 in 2000 and it grew or it was increased to 6.515 billion in 2005. And all the time we consider must be after 2000. So, how many years after 2000 is 2005? You just have to count 1, 2, 3, 4, 5, 5 years. So, t will be 5 years, just like that. But now over here in the first situation, we just have to write t years, that's it. And over here y. But what is the formula? It is y is equal to ae power kt. Now here this is positive k. Why? Because this is growth function. If it was decay, there will be minus if it's reducing. So let's start solving it. Let's see the given. Always remember this A is the initial population. If you have 2005 and 2000 populations, right, this and this, the A value will be the smaller one, in the sense the earlier one, that is 2000 will be A. So given A is equal to 6.124 billion people. Let's write in terms of billion itself. So that's it. And then what is the time? Because see, now we have to write the equation. To write the equation, what is very important? K value is not given. That is what we need to find. So now if we substitute everything, then we can find K value, isn't it? So let's try that. Now this is A. What is the time from 2000 to 2005? Time is 5 years. So this is years. And then what do we know? What is the final population? Y is after a certain time. If t is 5, after 5 years, the population y will be 6.515 billion people. So now we know almost everything. And E is Euler's number. That's a constant, 2.71. Now what we do is we'll just substitute. This is 6.515. Now this is a B. B is billion. Don't write this, okay? I'll just cut it off over here. Not 8, it's B. Equals, what is A? That is 6.124. E is Euler's number and K is the value we are going to solve for. And time multiplied by time is 5. Now how can we solve this? Now you can put this entirely in the calculator and get the answer, but let's do a simple step because it's in the writing part. I will take these numbers to one side and simplify as much as possible. So 6.515 at one side divided by 6.124. This will be equal to e to the power k multiplied by 5. Now you can take natural logarithm on both the sides. You can write another step. ln will be 6.515 divided by 6.124. That will be over here the right side, ln e to the power, I write 5k. Now what happens here, whenever you have logarithm, this whatever is there comes down, right? The property of logarithm, the powers will be the coefficients. So then ln and e is 1, so they cancel off the inverse, so it'll be 1. Then you can just put in the calculator and solve it up very easily. So then after this, it's very straightforward. So what you can do is write so much and then let's put it directly in the calculator and we'll get the answer. I'll show you now. All we have to do is see ln, that's natural logarithm, divided by 6.515 divided by 6.124, close the bracket, equals as alpha and equal to ln e is given as over here, shift and e to the power phi alpha x and close the bracket over here. That's it. Now you can just press, because we have the variable and equation, you can't press equal to, this is an error, it will give you a syntax error. You need to press shift and solve. This is not the answer, this is whatever was stored before. This is not the answer. You need to press shift, solve and then equal to, and this is the correct answer, 0.1237. So now many of my students used to ask me how many digits to write here, 4 or 5. In the textbook, sometimes they are taken 5 digits, sometimes 4. So what I would suggest is minimum number of digits to be taken is 1,004. Sorry, not 1,000, 10,000s. 4. 1, 0, it's sorry, 0, 1, 2. You can now round it off from 3, 7 to 4. Okay. Now in your solution sets, they might have taken 5. It's fine. Now sometimes you can write 0.1238. So if your answer is varying in a range, that is absolutely fine as long as you have done it correctly. Now technically minimum digits to be taken is 4. You can take even 5 or 6. Don't go more than 6. No one takes more than 6. So this is the K value. Now I'll just show you, even if you put this equation entirely in the calculator, you'll get the answer. Now, one thing, it will take time for your calculator to solve. It might take up to 20 seconds. So once you press shift and solve and equal to, wait for it. So let me show you over here. E is shift and ln, and over here alpha x multiplied by phi. And you just have to press shift and solve equal to. See, now this calculator is a computer simulation, so it gives it very quickly. The answers are shown very quickly. But when you have your physical calculator with you, it takes time. So please be patient. Don't press on or AC. It'll have to be redone then. So this is the same answer any way you do. That's the answer. But now look here. We just found the K value. For the part A, they have asked you the exponential equation. That's this growth equation. Now, once you find the K value, you should write y is equal to, what is the initial A? Population is 6.124. E to the power K is 0.0124 times T time. This is the equation, what they want in the part A. The K value was not known, so we did the formula, we substituted all the given and found the K, and then we got this. So that's the part A1. And you can see over here, that's the answer. Now we can leave that. Let's go to the part B. Now see over here, you might be thinking it's too much. It's fine. Whatever I've written over here is more than sufficient. This is all the important steps that are required. Then over here you can write this. So the population, whatever the question, again you can rewrite and tell this is the answer and all that stuff. So what I would suggest is write the given, write the formula properly and simplify it, and then leave some space. Again, you can write the formula and do the substitution of the equation. Now let's go to the second part. Use the equation to predict the year in which the world population will reach 7.5 billion. In fact, I need this because that's the equation, right? I'll keep it over here and I'll do the part B somewhere over here. This is all A, this is B. So the given will be the same for both, but just that over here now, this is done. This was only for the first part. Now the Y is given as 7.5 billion people. So they want to know when will it reach 7.5 billion people. All you do is use this, but instead of Y, I'll put 7.5 equals 6.124 e to the power 0.0124 times t. Now again, what do? Don't directly put this in calculator. Yes, you will get the answer, but just try to simplify a couple of steps. Let's take this to the other side. It'll be 7.5 divided by 6.124 equals e to the power 0.0124 times t. Don't take natural logarithm over here in the first step itself because there are two terms here. You have to use properties and stuff. So simplify the numbers. Now you can see this is a single term when you solve it, right? So now you can take ln on both the sides. It'll be 7.5 divided by 6.124. That is equal to ln e to the power 0.0124 t. That's it. Now use your calculator to solve for t. Let me show the substitution here. Use the fraction, ln fraction. It's 7.5 divided by 6.124. And let's close the brackets, equals, it is ln again, natural logarithm, e to the power that shift ln, it's 0.0124 to the alpha x. The t is written as the variable x. You don't you cannot put t or y. You have to use this variable x only. Don't use the other variables, because when you shift and solve, it doesn't give you the answer. Only x can be solved in the calculator, and that's shift and solve. This is the previous answer which is stored. Now when you press equal to, here you go, it's 16.34. That's the answer. Let's just double check. Yes. Now see here. Here the answer is 16.372, and here we got 16.34. That doesn't matter, because see here, they have taken 0.01238. Now we have rounded off to 4 decimals. So it's absolutely fine. Now I'll just show you over here. If I take it as 38, I'll just change this to 38 and shift and solve, then press equal to, your answer is exactly what the textbook is having. So don't worry, as long as you have done this correctly and you've got something related to 16 point, that's more than enough, and you will definitely get the full marks. Okay, I'll just stick to what I have written over here. That is shift and solve and then equal to, so the time it will take is, t will be 16.35 years, rounding off to 2 decimals. See, another thing is, the error is we take 2 decimals at one place, 3 decimals, or 4 decimals. It depends. I mean, this is not 3 decimal over here, 4 decimals, 3. So that's why there might be a minute error, but that's absolutely fine. You are technically supposed to get full marks for that. No problem about it. So that's the answer, guys. And so after 16.3, nearly after 16.37 years, from 2000, the population will reach 7.5 billion. So when does that happen? So it'll be in the year, which year? If you add 16 year, it'll be in the year after 2016. So that's it. So that's how we solve it. Let's solve this one as well. Jason wants to buy a new HD television, but he thinks that if he waits, the quality of the HD television will improve. The television he wants to buy costs $2,500 now, at present. That's now. It costs so much at the present. And based on pricing trends, Jason thinks that the price will increase 4% each year. So certain products will always keep on increasing its price after each year, right? Because of inflation and other stuff. So this increases every year by 4%. But the HD quality will improve as well. Write an exponential growth equation to represent price y of a new HD television t years from now. So now we have to write exponential growth equation. Y is equal to e to the power ae to the power kt. I just got confused for a minute. Now here let's write the given. So we know the initial price A is $2,500. We have this 4% here. That's the K value. Remember, we had another formula, A is equal to PERT in the question 1, right? So this R is the rate. Rate is always percent. Same formula here. Instead of A, we have Y. Instead of this Y, we have A, this capital A. Now P is replaced by A and E to the power KT instead of RT. RT and KT, right? So K is the rate, percent. So K is given as 4%, that is 0.04. That's it. Now, no other values are given. Let's substitute what we know and write the equation. Y equals 2,500 e to the power 0.04 t. That's it. That is it. That's the part A, because they have given you the K value and A value. It's so easy. That's why. Let's so that's the equation. Let's look into the next part. Use the equation to predict when a new HD television will cost 3,000 dirhams. So when will it cost? The final cost after a certain time is always Y. It's $3,000. So when will this be 3,000? Y is equal to 3,000 equals 2,500 e to the power 0.04 t. All you need to do is find the t value. You can put this directly in the calculator and get, but let's do some steps. I'll take this to the other side. It'll be 3,000 divided by 2,500. That is equal to e to the power 0.04 t. And now take ln on both the sides. So we'll be 3,000 divided by 2,500. That'll be equal to natural logarithm over here as well, 0.04 t. And now we can just put this in the calculator and directly we can get the answer of t. That will be the time it will take for this television. Every year, if it increases at the rate of 4%, it'll, after how many years, it'll reach 3000 basically. I have already substituted because we have substituted the same thing in the previous question, first question as well. So here we have 3000, 2500, ln 0.04, and t is alpha x. So alpha over here, this is the symbol, and x is over here. When you press that, you'll get the variable x. Shift and solve, and then press equal to, what's the answer? It's 4.5580. Now for time, I'll just take 2 decimal points, right? 4.56 years. So after 4.5 years, or nearly 4.6 years, this initial cost of 2500 will inflate to 4.56 years. So that's the answer. And you can write sentences, but as long as you have solved this properly and you have highlighted this answer, that's more than enough. It's 4.6 years away from now. They have not asked you to round out it, like in the sense rounding off is not mentioned, so you can write 2 or 3, whatever. But imagine they had told you round off to the nearest tenth, then only 1 digit after decimal point, and so on. Okay, it depends on the question. Let's move to the next. Okay, there is C part as well. Let's look into this. Jason decides to wait to buy a new television and saves his money. He puts $2,200 in a savings account with 4.7% annual interest compounded continuously. Determine when the amount in his savings will exceed the cost of the new television. Okay, this is interesting. What they are saying is, now he knows this television will initially cost 2,500 and it's increasing 4% every year. Now what he does is he saves in the bank $2,200, but that will compound every year 4.7%. So the same thing, what we did just a while ago, see this equation which we have written, right? See this one. Now we have to write again for this one. When will this equation be greater than this equation? In the sense, when will y money, okay, money which he puts is greater than y cost, I mean of TV, cost of TV. So this is the thing, money saving, okay, save. Let's write the equation over here. We know this equation was y will be a is the initial cost 2,500, e to the power 4% is 0.04 t. When will this be greater than, say 2,200 is the initial amount which is depositing, e to the power, what is 4.7? It'll be 0.047. You can put in the calculator directly and get the answer. So in the topic 1, we have already solved the such things and multiplied by t. So you can solve it directly in the calculator, just this inequality make it as equal to. But before that, let's simplify how much we can. So I'll take this 2,200 to the other side. You're remaining with E 0.047t greater than 2,500 divided by 2,200 e to the power 0.04t. Here you can put this in the calculator and get the answer, but let's just do 1 or 2 steps, because steps are important because it's writing exam, isn't it? We can take ln on both the sides, natural logarithm. It'll be e to the power 0.047t. This will be greater than ln over here. It'll be 2,500 divided by 2,200 e to the power 0.04t. Now when we what happens is basically ln becomes, because of the properties of natural logarithm, when you have 2 terms a and b, see, ln a multiplied by b will be equal to ln a plus ln b. So here we have this 2,200. This is one term plus ln e to the power 0.04t. Now you can easily solve this up. Get t to one side and solve it up. Over here, this and this cancels and you're remaining with basically only the above term, 0.047t. This is again another property of natural logarithm. Y e to the power x is equal to x. Whatever is up just comes down, that's it. So now we have this term, right? We have done so many steps. That's more than enough. I'll directly put this in the calculator and I'll show you the answer now. Here I've just substituted this equation 0.047 alpha x instead of t. T is the variable. Now here inequality is considered to be equal to ln 2500 divided by 2200 plus ln e to the power 0.04 t. So you just press shift and solve. This is the previously stored answer. When you press equal to, you'll get this correct answer, current answer, sorry. What I mean is it's t equals 18.26 years. So this is the amount of time you will have to wait if this money deposited will match whatever the cost of TV is. That's like forever is never going to buy the TV, you know. So practically no one's going to wait so much. But, you know, if we put so much money and for all this situation, this will be the time. That'll be the answer over here. See the inequality, just write at least a few steps. What we have written is more than enough. If you want, you can even continue more answers. And now round it. It's not mentioned to round off this answer to nearest 10th or 100th or 1000. So I've taken 2 decimal point, that's fine. Or you can do a single decimal point, it's years, you know, it's time. It'll take 18.3 years. So now we have half-life problems. Now these problems are decay problems. So here y equals a e to the power kt. The same formula, but you will have minus because it's decaying, it's reducing the amount. So this is very important. Now here what is given? You need to write given for every problem. I may not have written for all problems, but please do try to write it. Now given a radioactive substance has half-life of 32 years. So what is the time? It's 32. Now what is exactly half-life? Half-life is the amount of time taken for a particular element to come to its half of its initial amount. In the sense, if there is 100 grams of, you know, some substance which is radioactive. Now if 32 years is half-life, after 32 years, it will come to 50 grams. Then again after 32 years, it'll come to 25 grams. Then after 32, it'll come to 12.5 and so on. And there'll always be small, minute trace of that element. So that's about half-life. Here it's always in 32, it becomes half. So that's the time t. Now there is a very important thing. Whenever they mention half-life, there is a rule which you must remember. Y is always equal to half of a. Why? Because when you put this t as the half-life, t is 32 years. After 32 years of time, this y will be half of 50. If initial amount was 100, y will be 50, right? So directly we can take half a as y, that is equal to a e to the power minus, we don't have the k value, we have to find the k value, minus k, but we know the t value is 32. This is it. Now a and a cancels off over here, so you're remaining with half equals e to the power minus k times 32. Now take ln on both the sides. This is ln half, that is equal to ln e to the power minus k times 32. Now we can just use your calculator and solve it directly. I've substituted this equation ln half equals natural logarithm e to the power minus, that k value is unknown. Now we are solving for that, so that's x variable. This is multiplication symbol 32, and we can't press equal to, it will be syntax error. Let's press shift and solve. This is the last answer which is saved, and the answer over here is 0.02166. So what I'll write over here is k value is equal to 0.02166 will be 7. I remember long back one of the student asking me, this is minus k, so is this minus answer? No, when we solve it in the calculator, the minus sign is already accounted for. Whatever x value we get is, whatever answer we get is, that's it. If over here we have minus, then you have to put minus, otherwise that's it. So this is the k value. Now we will write the given equation. Y equals a e to the power minus 0.0217 t. So this is it. Now you can see that's the answer. Now here we don't substitute anything to A because it depends on the condition or the amount of a substance remaining or what was used. So that's the answer. Now, second one, how much of 5 gram sample of radioactive substance should be left after 100 years? Now, this is again very important. See, 5 gram sample, how much of 5 gram sample of a radioactive substance should be left after 100 years? So now initially you have 5 grams, that is A value, you have 5 grams with you. After 100 years, T of 100 years, this is B, this is A. If you spend a time of 100 years, how much will remain? Now we will use the same formula, y equals a e to the power minus kt. But now we have solved the situation, right? And we have got that. We should use this actually instead of k. But anyways, I'll write it again. Y is equal to, what is the y value? If a 5 gram sample, that is a is 5, e to the power minus 0.0217, and after how many years? T is how much? 100. This is it. So you have to just put this entirely in the calculator because there's nothing else to do. Here, remember, there is no variable, like x is on other side of inequality or equal to, sorry. So you just put this entirely right side thing in the calculator without any variables. So it's minus 0.0, sorry, it's decimal 0217 multiplied by 100. So here we get 0.57. So that is what remains. If you have a 5 gram sample right now after 100 years for this particular condition, only 0.57 grams will remain. So that will be the answer. See, 0.57. Another carbon dating problem, again the same thing, half-life is there. This is always decay, and they have also mentioned the way it's decay constant. Carbon-14 has a decay constant of K is equal to 0.00012. Use this information to determine the age of the objects based on the amount of carbon-14. So now here K value is given. Say the formula Y is equal to A e to the power minus KT, right, for decay. K value is already given. We need to see the condition and then solve how much time we have to tell. Determine the age. Age is the time. T we have to solve for. A fossil that has lost 95% of its carbon. Okay, this is very important, carbon 14. 95% is lost, gone. So how much is remaining? Only 5%, right? So what is this? 95% of the initial amount is gone. So imagine it was 100 grams initially. A is equal to 100. So what happened is 95% is gone. So 95% grams gone. So what's remaining? Y is basically 5 grams. That's it. Or you can always write such things as 5% of A, of the initial amount, right? 5% multiplied by A is 100 grams. You will have 5 grams. So this is the trick over here. Always remember, you should know how much is remaining, not the lost, how much is there. So if 95 is lost, only 5% is there. So 5%, that is 0.05. Okay, 5% is always 0.05. 0.05 times 100. That'll be 5. Now here 0.05 A, because that's 0.05 times the initial amount, is equal to AE minus, what is the K value? It's already given, 0.00012. When it's mentioned, don't go to round it off. Take the entire value whichever is given to you times T. A is gone. So you have 0.05 equals e to the power minus 0.00012 times T. And then you can just put this in the calculator directly and get the answer, or you can take ln on both the sides and still you'll get the same answer, e to the power minus 0.00012 times T. So I'll show you how we can substitute in the calculator. I've just substituted over here, natural logarithm 0.5 equals ln e to the power minus 0.00012 alpha x. You can write multiply and then write x, or directly write x, it's fine. It'll be multiplied itself. Shift and solve, not this. Press equal to, you will get the answer. It'll be 5,776 years. So the time taken is, okay, now there is some error which I did over here. I will keep that error because it's a very important error. See, look here. I have taken 0.5 in the question. See, one simple decimal point made the entire question go wrong. The answer is 24,964, which is the correct answer. But over here, I wrote everything properly, but just over here, I forgot to write the zero. So I thought I'll edit that part, but no, I'm just leaving that part, the error part. The reason being, because of that one single zero, my entire thing was wrong. So don't do that mistake in the exam. So for the 95% of the carbon to be gone, to be lost, it'll take 24,964 years. That's how we solve it. And there's a B part as well. The same question, but they're asking an animal skeleton has 95%. See, this is has, it's not lost. See, this is a very important distinction. 95% is a remaining, it is remaining. So here Y is 95% A or 0.95 A. So out of 100, if initially A was 100 grams, 95% remaining means 95 grams is still there. That's what it is. So here it's the same formula. Let me just take it off. You have to write given and everything for each question. Now the formula is given as Y equals AE minus KT. Why? Because minus is for decay. Now all you do is substitute this 0.95 A equals AE to the power minus 0.00012 T. And now here this A and A cancels off because both are initial amounts. And here you have 0.95 equals E to the power minus 0.00012 T. And take natural logarithm on both the sides and just put it in the calc ln over here. Minus 0.00012 T. And now we will substitute in the calculator and solve it up. So here I've just changed that 0.095 and then everything was same. And we'll press shift and solve and then equal to, here it just takes 427 years. You can see here, time is 427.44. In the exam, you can write at least 1 or 2 decimal points. They have not mentioned anything about the decimals. So just write 427.44. Don't write many decimals, just 2 is enough. Maximum 2 or 1 is enough. Even if you write whole number, it's okay. So that's how we solve these problems. And this is the last problem in this. It's about half-life again. Half-life is decay, so it's Y equals AE power minus KT. Let's look into the problem now. Archaeologists uncover an ancient wooden tool. They analyze the tool and find that it has 22% as much carbon compared to the likely amount that it contained when it was made. Now what this means is 22% of the carbon amount is remaining, it has it. So initially if A was 100 grams, now Y is 22% of 100, that is 22 grams. So this is Y. Okay, so that is the thing. So now in this case, you need to write given, but I'll directly substitute over here. Y will be 22% is 0.22 A equals AE to the power minus, what is the K value? Carbon is always having 0.00012 and time is what they require, isn't it? So when it was made, given that the decay constant of carbon 14 is 0.00012, about how old is the artifact? Now we just solve this up. A cancelled, seem like what we did a while ago. 0.22 equals E to the power minus 0.00012 T. Let's take ln on both the sides. And that will be equal to ln over here as well, E to the power minus 0.00012 T. And now what we do is we use the calculator, directly find T. You can see here it's ln 0.22, ln the negative 0.00012 alpha x is for the time. Just shift and solve and then equal to, your answer will be 12,617 or nearly 18 years. So it's 12,618. It's rounded off to the whole number itself. That is the answer. So simple as that. You do not need to do all the entire steps. Whatever I've shown over here, that is more than enough. And then directly write the T to 12,000 and so on, right? That is enough. So that's it. And if you want, you can even write the same thing, last part of the question. The artifact is, or the wooden tool is about, the answer, whatever you get, so many years old. So that is the end of question 2. Please make sure you remember the formulas, write the given, substitute, and then do a couple of steps, and then finally put it in the calculator and then solve for the answer.